I'm Juliet, and today we are going to explore the use of the technique of trigonometric substitution.
By definition, trigonometric substitution is an integration technique that converts an algebraic integral containing expressions of the form square root of a squared minus x squared, square root of a squared plus x squared, and square root of x squared minus a squared into a trigonometric integral. The goal of this integration is to replace square roots of quadratic expressions or rational powers of this form n over 2, where n is an integer of quadratic expressions, which may be impossible to integrate using other methods of integration, with integer powers of trigo functions, which are more easily integrated. So here, you need to be familiar with standard trigonometric identities, use of differential notation, integration using use substitution, and integration of trigonometric functions. Now, let us explore the three integration forms wherein we substitute x in a particular value and a is constant. In the first case, we let x is equal to a sine theta for square root of a squared minus x squared. In the second case, x is equal to a tan theta for square root of a squared plus x squared. And in the third case, x is equal to a secant theta for square root of x squared minus a squared. So why do we do that? Well, we just applied the Pythagorean theorem for this integration technique. As you can see on the first triangle, we let a be the hypotenuse and x be the opposite side. Then the adjacent side will be the square root of a squared minus x squared. Notice that the sine theta is defined as opposite over hypotenuse, which is x over a, so therefore x becomes a sine theta. On the second triangle, we let x be the opposite side and a be the adjacent side. Then the square root of a squared plus x squared becomes the hypotenuse. Notice that the tan theta is opposite over adjacent, which is x over a by definition, thus x equals a tan theta. Then, on the third triangle, we let x be the hypotenuse and a be the adjacent side. So the opposite side will be the square root of x squared minus a squared. Now we realize that if we take the cosine of this angle, it is equal to a divided by x by definition, but the second is the inverse of the cosine, which is x divided by a. Therefore, x becomes a secant theta. This resubstitution for x into our integral will make it much easier to solve the integration. Now, let us go for examples. Integrate x squared over square root of 4 minus x squared dx. So first, identify the a and the trigonometric integration to be used. As you can see, the square root of 4 minus x squared matches the first case. So, a is equal to 2 and x is equal to 2 sine theta. Then, get its derivative, which is 2 cosine theta d theta, and substitute it to the whole equation. So it will become integral of 2 sine theta squared times 2 cosine theta all over square root of 4 minus 2 sine theta squared d theta, and simplify it. Let us recall the trigonometric identity sine squared theta plus cosine squared theta equals 1. When you derive the trigonometric identity, it becomes 1 minus sine squared theta equals cosine squared theta, and then substitute it. Simplify it again. Thus, you will get the integral of 4 sine squared theta d theta. Let us recall another trigonometric identity. Sine squared theta equals 1/2 minus cosine 2 theta all over 2. Then, you can evaluate the integral. So you will get 2 theta minus sine 2 theta plus c. Then, you need to go back from the first step and you need to use a reference triangle to write the result in terms of x. As you can observe, 2 is the hypotenuse and x is the opposite side. So, the square root of 4 minus x squared is the adjacent side. In able to rewrite the result in terms of x, there are two steps. First, you need to get the value of theta. In able to find the value of theta, derive x equals 2 sine theta. Then you will get arc sine x over 2. Second, you need to recall the trigonometric sine 2 theta equals 2 sine theta cosine theta. Sine theta is x over 2, while cosine theta is the square root of 4 minus x squared over 2. Finally, substitute all these things and simplify it. Thus, the answer is 2 arc sine x over 2 minus x squared root of 4 minus x squared over 2 plus c. So that's how we apply trigonometric substitution to solve integrals. Here are some reminders in using trigonometric substitution. Trigonometric substitution is usually used when we have radicals within the integral sign. There are three basic cases, and each follow the same process. The only difference between them is the trigonometric substitution we use. Remember to find dx as a function of theta before you actually make the substitution. Apply trigonometric identities if necessary. Use a reference triangle to rewrite the result in terms of x.